an aluminum and plutonium cylinder burns up in Saturn's upper clouds. It disintegrates at 112,000 kilometers per hour. Why did the most successful mission in the solar system need to be intentionally destroyed? The answer wasn't a mechanical failure, but a discovery hidden beneath the ice of a distant moon. A revelation that forced scientists to make a drastic decision to protect a world we barely knew. The Cassini space probe spent 13 years mapping the sixth planet from the Sun. It photographed gigantic hexagonal storms, measured the thickness of ancient rings with meter precision, and revealed landscapes that were until then mere blurs in Earth's largest telescopes. During its journey, the spacecraft sent a lander module to Titan's haze-shrouded surface and orbited Saturn 294 times. But the mission's absolute success carried the weight of its inevitable demise. On September 15, 2017, the continuous stream of data vanished forever. Mission controllers watched in silence. The destruction of the probe was the final chapter of a journey planned for 30 years and executed with relentless mathematical precision. If you've come this far, it's worth subscribing. Each week, a new expedition to the cosmos with real NASA data. This relentless precision began 20 years earlier, when the gigantic Titan IV rocket waited on launch pad 39 and 40 in Florida. It was October 1997. Atop the rocket rested the largest and most complex interplanetary probe ever built in an international collaboration. It carried 5,700 kilograms of scientific instruments, powered by radioisotope thermoelectric generators. The spacecraft carried 12 American instruments and a European lander module named Huygens. Its destination was 1,200,000,000 kilometers from Earth. The journey demanded an indirect, calculated route. The probe executed close flybys of Venus twice, then Earth and Jupiter, using each planet's gravity as a slingshot to gain speed in the vacuum. 7 years it spent traversing the dark, silent expanse. On July 1, 2004, Cassini fired its main engines for 96 continuous minutes. The fuel burn reduced the spacecraft's speed, allowing the gas giant's immense gravity to definitively capture it. For the first time in the history of space exploration, a machine entered orbit around Saturn. And in the very first photographic scans of the ring system, a small white dot reflecting sunlight altered the course of the entire mission. This small white dot was Enceladus, a sphere just 500 kilometers in diameter. It's so bright that it reflects almost 100% of the light it receives from the sun. In the first images captured by the probe's cameras, the surface appeared to be a dead, frozen ice desert. The landscape was marked by ancient craters and deep fissures at the South Pole, which scientists nicknamed tiger stripes. But the Cassini instruments registered an unforeseen physical anomaly. Saturn's vast magnetic field was being bent and decelerated around that small moon's south pole. Something invisible and massive was pushing the space plasma. The navigation team altered the probe's trajectory to investigate the anomaly close up. In 2005, Cassini executed a close flyby, passing a mere 175 kilometers from Enceladus's ice crust. The high-resolution cameras recorded the unexpected against the dark backdrop of space. Immense jets of material were being violently ejected from the polar fissures. The moon wasn't a sterile block of ice. It was expelling tons of liquid water directly into the vacuum. But the water wasn't merely escaping into space. It carried a chemical signature no one expected to find so far from the sun's habitable zone. How could we prevent our own exploration from contaminating a potentially habitable world? The control team decided Cassini needed to fly directly through these vapor plumes. The onboard mass spectrometer captured the particles and analyzed them in real time, traveling at thousands of kilometers per hour. The data transmitted to Earth revealed the presence of salts, methane, and complex carbon-rich organic molecules. Later, the instruments detected silica nanoparticles. These particles only form when very hot liquid water interacts with solid rock. The chemistry indicated that beneath Enceladus's ice crust, there exists a heated global ocean. The readings pointed to the existence of active hydrothermal vents at the bottom of this alien ocean. It's an environment incredibly similar to the volcanic vents on Earth's seafloor, the exact locations where biologists believe life may have begun. The mission found one of the most promising environments for astrobiology, but the weight of this discovery transformed the probe's physical structure into an imminent biological risk. The imminent biological risk became the primary focus when the hydrazine gauge on the telemetry panel indicated critical levels. It was late 2016. Without fuel to correct its orbit, Cassini would soon become a dead artifact, drifting aimlessly through the Saturn system at the mercy of complex gravitational perturbations. The danger of an accidental collision with Enceladus or the moon Titan was mathematically probable in the long term. And even after 20 years in the extreme environment of space, terrestrial bacterial spores could have survived within the spacecraft's heated interior, protected by the continuous warmth of plutonium. If the aluminum structure fell into Enceladus's warm ocean, Earth's microbes would find a perfect habitable environment to multiply. This contamination would permanently destroy any chance of discovering untouched native life in the future. To protect the moons, the agency designed a bold final maneuver. They programmed a series of 22 close orbits, forcing the probe to dive into the unexplored 2,000-kilometer gap between the innermost rings and the planet's upper atmosphere. With each pass, the probe dove deeper. On its final orbit, the colossal gravity pulled the spacecraft into the planet's ultimate embrace. The thick layer of ammonia clouds swallowed the aluminum probe exactly as the navigators had planned. The most successful mission in the solar system needed to be intentionally destroyed to ensure the hidden oceans itself discovered remained pure. The radio signal carrying the last data took 83 minutes to cross space to the antennas on Earth. When the green line on the lab's telemetry screen went flat, silence enveloped the control room. Cassini fought with its small thrusters, firing at 100% capacity to keep the antenna pointed towards us, transmitting unprecedented atmospheric data until aerodynamic forces tore it apart. In our next episode, we'll investigate Apollo 13, how NASA brought 3 men alive from a space disaster. An explosion thousands of kilometers from home transformed a routine lunar mission into a race against the clock and orbital physics. The metallic atoms that once formed the spacecraft now float dissolved in the gas giant's equatorial storms, while the small ice moons continue their orbit in the dark.